All right, so here's a video about filling out our learning card for simulations. We want to fill that out. So we're going to work on learning cards for simulation right there. You can see that. So I'm going to zoom in a little bit so you can see this a little bit better. We'll start right here. A simulation is an imitation of chance behavior, usually carried out with random numbers. So a simulation is an imitation of chance behavior, usually carried out with random numbers. So now we have these big letters on the side that don't really spell anything. It says Sims C, but each letter kind of stands for something. So we're going to start off by filling out the first one, which says state the problem or question at hand. So for this particular problem, what we're really looking at is this example over here. So in the end, what we want to look at is, what is the question? What question are we trying to answer? Well, in this case, we're trying to answer, what is the probability that all three coins come up the same, all heads or all tails? You've got to know what the question is in order to get to your answer. So state the problem with the question at hand, or highlight it if you need to highlight it. The second thing that we want to look at is the I right here. And the I stands for independent events or other assumptions. We're going to focus on the independent events. We really want to look at here with independent events is we want to know if the events are independent or dependent. If they are independent, then what we can say is this. Independent events, what we can say is that repeats, are okay. I say that again, if the two events are independent, then repeats are okay. It's okay if you get the same number again when you are going through your simulation. If the events are dependent on each other, that means that repeat values are not okay. So if I'm going through with a random number table and I come up with the same number twice within a trial, then that's no good, and I want to skip over that repeated number. I come to M, which stands for map the digits. When we map the digits, what we really mean is state what each digit represents. That's what we're looking for here. State what each one of the digits represents in your random number table, or if you're using your calculator. We get to the S, which is just simulate. And that means run multiple trials and tally the results. That's all it means when you get to the simulation, run multiple trials and tally the results. And finally, we get to the end here, which says conclude by answering the original question given your simulated results. All right, so now let's get to our example. So it says a three-way tie to be broken with coin flips. Each team tosses a coin. The odd man out meant that whichever team's result was different, that team is out. When all coins come up the same result, TV reporters seem amazed that this happens. What's the probability that all three coins come up the same, all heads or all tails? Now there's a lot of information there, but we actually want to start off by stating the question or highlighting and just knowing what the question is. What's the probability that all three coins come up the same, all heads or all tails? That's what our focus is going to be. That's the question that we want to answer with this simulation. So when we run our trials, what we eventually want to do is answer this question based on the results of our trials. Next thing we need to ask ourselves is, are these events independent? So the event that we're looking at is flipping a coin. That's what we're looking at, is we're flipping a coin. That's the component that is being repeated over and over. So are they independent? Well, yes. When I toss a coin, each coin toss is independent of the others. So repeats are okay. It's totally fine that repeats happen. Repeats are okay. So I got to remember that as I run my trials. The next thing I want to do is map the digits. So as I map these digits, I'm going to be using a random number table. Let's assume we're using a random number table for this example. So I'm going to let 0 through 4 equal heads and 5 through 9 equal tails. Now the reason that I'm doing that is because when I toss a coin, it's a 50-50 chance. So, I've got a 50-50 chance or there's a 50% chance that I'm going to get heads and a 50% chance I'm going to get tails. So 0 through 4, half of the digits are heads, and 5 through 9, half of the digits are tails. Next, we go ahead and simulate with the trials. So we run multiple trials, and we record those results. Now, I'm not going to go through running a trial and using a random number table in this particular video for this learning card. There are plenty other videos out there that show that. Some of them are mine, some of them I've linked on our class page. But I'm going to assume that you know how to run these trials as you're filling this out. But now what you want to do is make tally marks. So let's say that what we ended up with was the 3 coins ended up being the same. Let's see, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they were different. Let's see, 5, 10, 15, and 20. Let's say I run 30 trials, and these are the results. So 10 times the coins, all 3 were the same, and 20 times the 3 coins ended up being different. And these were the results of the simulation. Now that we have all of these trials run and we have our data values, we can write our conclusion. So in this conclusion, I've said, based on this simulation, the probability that all 3 coins come up the same is about 10 out of 30, or 33.3%. This is not that unusual. Now, there's a couple of things I want to point out here with this conclusion. The first thing is this phrase, based on the simulation. What you're going to find is that whenever you write your conclusion, you should write a little phrase at the beginning talking about what you did. If you ran an experiment, you would say, based on this experiment. If you ran a survey, you would say, based on this survey. This is a simulation, so you say, based on this simulation. And then you answer the question. Let's remember what we had up here at the beginning. What is the probability that all 3 coins come up the same? Well, now I'm answering that question. The probability that all 3 coins come up the same is about 33.3%. And then I make a little comment based on this result. I could stop there, but I really want to, draw a conclusion. Well, if I go back up here to the original question, it says, TV reporters seemed amazed that this happened. Well, they're amazed because they think it's unusual. Well, in this case, 33%, 1/3 of the time, that's not very unusual. So in my conclusion, I've got, based on this simulation, because we were running a simulation, I've answered the question, and really I've used the question, what's the probability that all 3 coins come up the same? The probability that all 3 coins come up the same is about 33.3%. And then I've written a comment drawing some conclusions that this is not that unusual. I hope this helps, and have fun in your stats class.